Okay, hi. So welcome to this lecture named What is Testing? And I'm Daniel Tall. So, what is testing? And this is the content of this lecture. And first I'm going to tell you what testing is and then what it does, and then a little bit about two concepts that is called validation and verification. And also a little bit about the purpose of the software and how that affects the testing effort. And finally, an example of exhaustive testing and why that is not feasible. This is pretty much Somerville, page 227 to 228, and a little more that I put in also. So testing is to show that a program does what it is intended to do, and to discover defects before we put it into its final use. This was the sentence from Somerville book. What is intended to do, that should be specified somewhere, and the kind of specification that we have is requirements, that is use cases and things like that. Show what that a program does something. To do that, we need to run the program. So we run the program and we look at the output from the program. It could be text output, it could be an HTML page, it could be some kind of, if we're developing a game, we look at the graphics of the game and stuff like that. And then we get something that I call the actual behavior of the program. So we expect something and then we get something actually. We discover defect or bugs or whatever faults that we can call them, by comparing the actual, what we get from the system, to the expected behavior that we get from the requirements. And we compare these two things and and then we can discover if these are the same or not. A test case is if we have a specific input so that we get a specific actual output from the program. And then we have also, together with that, we also have the expected output. For instance, if we have a program that is adding two numbers, then and these numbers could be any integers or something like that, 3, 4, 5, and yeah, something like that. And then we get some output from that system. So a simple program just adding two numbers. A test case for this could be, specific input could be like, okay, let's add 3 and 4, and the expected output for that would be 7. Together, that test data, that input, and that expected output is a test case for the specific certain system, the add method. Testing does check the conformance of the system to its requirement or its specification. That means that we see how well these two overlap, or if they don't overlap, if there are things in the specification that we don't have in the implementation or didn't succeed to implement. By doing that, we build confidence for both the developers and the customers in the software and in the code. So developers need confidence in the code to dare change the code and to dare add things and know that they're done and that they've done a good job. And customers, they have ordered us to build a system for them, so they want the system to work as they specified it. They want to make sure that their needs are implemented in the correct way. So testing does uncover problems in an implemented system. So we have developed some code, now we need to see if that code works. Just because a developer thinks it works, it does not mean that it works. So we uncover problems or defects or bugs that were implemented by accident, just by a programmer made some error or did misunderstand something or so. So by doing this, we build a deeper understanding of the system, but we also get a better understanding of the requirements. So when you get a system running and you can see the output, and perhaps the customer can see the output and tests the system and sees the output, the customer can also understand what kind of requirement that should be there, because these can clear up some misunderstandings between the customer and the developers. And then there are two concepts, and these concepts are specified in the book. So the first concept is pretty wide. It's a general concept of validation. Are we building the right product? So we want to know if the thing that we got from the developers actually meets the customer's expectation and needs. So if we have a list of features for the programmer as specified by from the customer, we can test that we got all that by creating a test case for each of these features and see that the feature exists in the system that was implemented, and that it does what the customer expects it to do. So if we implemented a web store, perhaps, that you can actually buy things in that store, and that the customer, perhaps the web store owner, actually gets sales, could sell products through our web store. The other concept, and easy to mix up these two, is verification. And that is, validation was, are we building the right product? And verification is, are we building the product right? So did we do good when we implemented the product? So this is to check that the software meets its stated functional and non-functional requirements. So in order to do verification, we need a specification that tells us what is correct. So you need a specification, and now if we have a specification of the product, then we can check if that is the same as being implemented. So if we find a mismatch between the specification and the actual implementation, then we're doing something good when we're doing verification. So we try to find defects in the code by finding some kind of input for which the behavior actually, or the output of the program, is incorrect, does not produce the same output as expected when reading the requirements. So validation is a bit more vague, a bit more general. This is about what the customer needs and what kind of system the customer should want. And the verification is that, okay, now we've tried to capture what they wanted. We created requirements from that, and did we implement the requirements correctly? I just want to put out a short warning here. There's a concept called program verification, and this has to do with each other, but is not the same. So program verification is that we do a mathematical proof that a program works correctly for any input, and that will prove correctness, and that is not testing. So keep these concepts separated. So program verification and verification is not the same thing. So okay, so now we go into how much work should we put into our testing effort, and it depends on the software purpose. So if we have that way, I should point, Age of Conan, a computer game, if there is a problem in the game, like in this picture from Age of Conan, where there should be some kind of animal that this rider is riding on, but it's disappeared, so the rider seems to be in the air. It's a pretty funny bug, but and no one will die from this bug. Perhaps someone laughed themselves to death, but no one dies. And there is, well, I guess, a lot of money involved in developing Age of Conan, but it's nothing compared to what I have on the other picture, which is a picture of the Ariane 5 rocket, which exploded because of a bug. You can search for Ariane 5 rocket failure on YouTube and watch it when it flies up in the air, and then because of this bug decides to do a 90-degree turn and then explodes. It's quite exciting video, but if you like explosions. Okay, so if you are developing a game, you perhaps don't spend as much effort in testing as if there are millions and millions of dollars involved, or if there are lives at stake. So the amount of testing depends on the purpose of the software. It could also depend on other things, like if we are developing a product that is the first thing on the market and we want to get it out there before any competition gets it out there. Perhaps we reduce the effort of development and can live with more bugs and stuff like that. You can read a little bit more in the book about that. Okay, next slide. This is the test selection problem, and this has to do with if we are creating test cases. Which test cases should we create? Can we test any input and then like prove correctness, like we talked about program verification in a few slides ago? But that to try any input to test the program for any mouse clicks, for any text input or whatever, is impossible for most application. So I just to showcase this, I have a toy example here. We have the add program again. Actually, we have a faulty version of the add program with a bug. So this add program takes two integers, a and b, and should add them with a plus operator. But I've introduced a minus operator, a small bug. Since we have two integers as input, the input domain, the range of possible inputs, is any combination of these a and b. So if we use 32-bit integers, then we have something like minus 2 billions to 2 billions as the range for one of these input, and then you multiply that with the range of the other input, and then you get the number of test cases you need to do exhaustive testing. So exhaustive testing would be to like send 0 and a 0 and 0 and a 1 and a 0 and a 2 and all possible test cases, and then we test it, and then we know that it works for any input. I put this really simple example up here because I wanted you to realize that perhaps for such a simple method we don't need to do exhaustive testing. It's impossible, and we don't need to do that. It would take just one test case to discover the bug, and perhaps one more or so to be absolutely certain that we got the right operator. So I mean, if we send it a 3 and a 1, that should result in an expected output of 4. But if we send it a 3 and 1, we get a 2 instead as actual output, and we compare the 2 with the 4 and realize that, okay, we have a bug in our system. So the test selection problem is to, instead of doing exhaustive testing, which takes forever, select a number of tests so that all bugs are revealed. We don't know if there are bugs there. There could be millions of lines of code in a software. This is not as simple as it sounds by the add example. Yeah. So we need to be smart when we select our tests. So the conclusions for this lecture is that testing is to run the system and finding faults, problems, bugs. We compare the expected behavior with the actual behavior. The expected behavior, we got that from the requirements, and the actual behavior, we got that from running the system with certain inputs. Validation was a more general concept, and verification was to check the conformance to the requirements. Validation has to do with what the customer actually needs. Are we creating the right system? And verification is, are we creating the system right? We cannot test things exhaustively and cannot prove that a program is correct if we don't use program verification. Okay, thank you.